Good morning, guys.
Hello.
I had small technical problems. We all now depend on electronic devices. My God, I continue. Oh my God. You cannot see me, right?
I can see.
I can see
Just
you.
one sec. I don't know what is happening today with that. Can you see me now?
Yes.
Yes.
Excellent. So, I first, as I do that all the time, I will check attendance, and after that, we will talk about coming test. You can write it down that I will offer you a test the next time on coming Thursday, because I do not want to shock everyone with the test right at the first week after our break. And beside that, I would like to ask you if you checked your emails. Did you receive my email with the link on the video, recorded video for our lecture just before the break?
Yes.
Yes.
Okay, this is recorded on YouTube, and I purposely sent it to you right now. So I think if you need to review something, I hope you took really nice notes last time, but if you like, you can watch that video again.
So the exam will be next Thursday?
Yes, but it will be not for entire meeting, because it will be for 1 hour, as we usually do that in our class. One academic hour is equivalent of 50 minutes. And I'm planning to do that using Pearson.
Okay.
Because it is not face-to-face class. Definitely, it can be done using many different methods, but I already approved one of other methods with my other class. They are not using Pearson, they are using Wiley Plus, the quite similar product to what Pearson has. But I did not do that through their electronic product, and decided to actually switch to that method, which is more accessible in today's reality. Okay, so this is why I definitely need to tell you that I'm going to start a new chapter today, because I cannot stay on the same material over and over and over. I did not offer you a test today because I'm just planning to give you a little bit more time for better review, so you would be able to review material, because again, so many things depend on how well you remember values, properties, main properties of the families of functions, important formulas. We covered so many details in chapter 2, and definitely chapter 1 was the review of material. I will not give you many problems. Definitely you will be having a beginning time and ending time for that test. You will be doing this using your own screens with access to Pearson, because you know how to do that. You are using Pearson for homework and online quizzes. It will be in the same way type of material. The only thing, it will be named as a test. Is it clear?
Yeah. Yes.
Would you like to ask
Yes.
me about anything so far before I actually started lecturing?
So just to be clear, it will be on April 16 at the same lecture time?
No, why do you say April 16? 1 second, please. Let me look at the calendar.
April 9.
Yeah, 1 sec. 1 sec. I am grabbing mine. 16, it is Thursday on the coming week. No, it will be on April the 9th.
Oh, okay. I thought you said next week.
No, I said coming. Maybe I accidentally said next. No, no. It is on this week. I did not want to give you a test right away as you return, means today. Because again, it is a break time, so I did not want to shock anyone. But even though I told you to use that break time to review the material, and as you remember, just before that break during our last meeting in March, which was 26th of March, we had quite detailed review using chapter review for the chapter. So you have all these problems should have in your notes if you took that note. More questions? No?
No.
And again, I sent everyone yesterday a link for our last lecture, which also has all these problems which we solved reviewing our material. Right now, I will briefly tell you what will be covered today. So this is a material from your textbook. So if you look at the topic for chapter 3, it says Analytic Trigonometry. And this is a monstrous, big, long chapter. The material here, every single designed in that way that in every single section, we will be getting tons of different new formulas, new definitions, new type of problems, and each section is very, very big. So section number 3.1, which I'm going to work with today, starts on page 182. 182. So let's actually go to that page, and you can copy the topic of that section for today's lecture, the inverse sine, cosine, and tangent functions. The topic is the inverse sine, cosine, and tangent functions. And you can start actually reading that from your electronic devices or from your textbooks, while I quickly right now check attendance, because I need to know right now. I can see names definitely, but some people probably are not here yet, so but they are arriving virtually. So, and this why please reply as soon as you hear your name. Bryce?
Here.
Gracia?
Here.
Alexia?
Here.
Stephanie? Hannah?
Here.
Andrew? Dimitar?
Here.
Benjamin? Kyra? Jesus?
Here.
Ariana?
Here.
Axel?
Here.
Desiree? Lila?
Here.
Lila, I think you received my email, right?
Yes.
Okay. So, Bhaktima?
Here.
Jessica?
Here.
Ivuna? Devin?
Here.
Valeria?
Here.
Excellent. Thank you, guys. That's it. Did you write the topic? Excuse me, did you write the topic of the lecture?
Yes.
Yes.
Even in chapter number 1, we talked a lot, reviewing functions, we talked a lot about inverse functions, because quite many functions have inverses, and not only trigonometric functions definitely have inverses. But at the same time, we need to mention that not every single function has its inverse, even being a function, because again, not every graph or every table or every equation represents a function. And we definitely can easily define if, let's say, given equation or a given a graph or a given table represents a function or not. Because if it is a graph, everyone practically heard about a vertical line test to check if it is a function or not. If with every vertical line test, we have only one point of intersection, it means that it passes that vertical test line. And in this case, this graph represents a function. If we have an equation, we need to solve it for y to see how many values of y we can get for every single value of x. If for every single value of x from the domain of that function, we can have only one unique value of y, it also means that we are dealing with the function. If we have a table, it can be done even easier also, like with the graph, because we can look at all values of x in, let's say, x column, and just see how many y's we have for every single x. But before we do that, we usually look at the table, because sometimes in the table we can see two matching x values. If in this case, if you do not have a matching x values, you just look at y's, how many y's you have. If you have matching x values, immediately look what kind of y values you have for matching x's. If, let's say, 1x is equal to 2, but y equal to 5, for the second x, which is 2, y equal to 7, it is a violation. It is not a function, because for x equal to 2, you can see 5 and 7 as y values. It is not a function. But if even they are located at different spots in that table, for one x, which is 2, you have 5. And for another, which is much below, let's say the first one, also x is equal to 2, and you again have y equal to 5. Even though it is written twice, but for each x equal to y, you have x equal to 2, you have y equal to 5, which means for 2, you have 5, which means it is a function. This how to check if it is a function or not. I just reminded this to you. Now, how can we check if our function is invertible? If we say that function is invertible, it means it has its inverse. For that case, we are using the easiest line test, which we call horizontal line test. And I'm going to show right now how we can use that horizontal line test. Again, it is not a new material, because this material you covered in Algebra 120, because in that class you covered families of exponential and logarithmic functions. And I will sketch, and I actually recommend you to do the same thing. And sketch a curve and name it f at x. If you pretend that you are sketching a vertical lines, can we say that it passes the vertical line test?
Yes.
So it is a function. Thank you. Because this is what you need to check first. If it is not a function, there is no sense of talking about being invertible or not, because definitely if it is not a function, it does not have any inverse. Did you sketch this graph?
Yeah.
And let's see if this is invertible. Sketch one of or two horizontal lines this time. This is again so-called horizontal line test. How many points of intersections do we have with each of these lines?
1.
That's it. It means it passed that test. Yes, we have, and I'm making even them bigger as dots. I'm showing these 2 points. It is an invertible function, which means it has its inverse. Fx has its inverse. How can I write it down? Like we usually do that in math, and it is an international symbol. For some people, it can be maybe a little bit confusing because it will look like a negative first power, but it is not. F minus 1x. I am going to inverse function. I'm going to show it to you right now. So f minus 1, we can say inverse for f, or f minus 1x. This is inverse symbol for function, which is inverse for f at x. Did you write it down?
Yes.
Yes.
Excellent. But there is a catch. Right now, if we start talking about trigonometric functions, I will simply right now sketch, let's say, sine x function, just first one. We have 6 direct trigonometric functions, and I'm planning to talk right now again about y equals to sine x. What can be either of these basic function in family of sines? We talked so many times. It has amplitude equal to 1. I am sketching, please sketch. Same thing. 2 horizontal lines, one passing through through 1, y equal to 1, dashed line. The other one passing through the y equal -1. Just, I will show what I'm doing. I'm just, again, preparing this for our y equal to sine x. So, period is 2 pi, because omega is equal to 1, and that is 2 pi over 1. So I'm showing 2 cycles, which means from -2 pi to +2 pi. As divide each of these intervals into 4 congruent pieces, as we all the time did. Just 1 second. This is what we usually did 100 times already. Preparing and labeling. Does it look familiar?
Yes.
So, and now sketch that graph. It will be a wave. Up, down, more up, and I'm sketching this spreading this to the second cycle. Again, we did it many, many times. And this is our wave. This is our graph of y equal to sine x. So far, so good?
Yes.
And now I like to check if this is a function which we can call like invertible. First of all, x-axis, is it one of horizontal lines?
Yes.
Can you see how many points of intersection do we have even on this graph? 1, 2, 3, 4, and 5. I'm talking about all these points. This one, this one, this one, this one, this one. But let's say we like to show additional one, additional horizontal line. And oh my God, 1, 2, 3, 4. But we showed our graph only in 2 cycles. Domain is a set of all real numbers, which means we can continue forever this graph into both directions. So we will get infinitely many points of intersection with that horizontal line. Do you realize that?
Mm-hmm.
Yes.
Which means it is failing that test. So, but now we have a natural question. How come we have a failure of that test, but at the same time, that first section here is devoted to inverse signs? And there is the trick. We are not going to consider right now this graph of sine, not only, let's say, in its entire domain, which is set R. We will not consider this graph even sketched in 2 cycles. We are going to choose only that central piece of that graph, which will have only 1 point of intersection with each horizontal line. And I'm going to show right now part of this graph in the very thick curve. You will see right now, I will show it to you, and you will understand which part I'm talking about. I am making this more thick than the rest of the curve. So you will see that on the screen. It will be quite thick part. Can you see?
Yes.
Yeah.
And now just concentrate on this part. On this part, yes, we have a graph of y equal to sine x, but only between x equal to negative pi over 2 and x equal to positive pi over 2. Is it passing horizontal line test just for this thick part?
Yes.
Yes.
So which means that thick part of the entire graph is invertible. This why, for this particular section, we will be absolutely ignoring all other values outside of this very small interval from negative pi over 2 up to x equal to positive pi over 2. We just need this part. So basically, we are changing the domain of that function right now, because our goal to see invertible part of this graph. So this y right on the top of this graph, I am not going to write anymore that domain is set R. I'm going to write that domain for me right now is closed interval from negative pi over 2 to positive pi over 2. And yes, on this particular domain, this function y equal to sine x is invertible. In other words, and I'm going to show that on this circle. Just 1 second. I am trying to sketch this in the nice way. If we are talking about the circle, our unit trigonometric circle has its center at the origin. At the same time, radius can be different. If we talk about unit trigonometric circle, radius is equal to 1. I am going to sketch part of that circle in the dashed curve and part. Oh, my circle looks as a perfect orange. And I'm shading that part which I just talked about. Can you see what I did?
Yes.
Yes.
Because I'm talking only about interval between negative pi over 2 and pi over 2. And I cannot name now that point representing negative pi over 2. I cannot call it like 3 pi over 2 because I am not using the dashed part of that circle. I ignore completely that part which has dashed in borders. This why I can only go from 0 down, reaching negative pi over 2 as an angle, or going up from 0 on the circle, reaching positive pi over 2. And I will try right now to show 1 or 2 angles in this shaded part. And this is again, we are using a unit trigonometric circle. Let's even write down that our radius is 1. Now, in the unit trigonometric circle, what is the definition of the sine? Is it equal to the y coordinate of the endpoint?
Yes.
So you can have angle, let's say alpha, alpha. I'm showing that angle, alpha. You can see alpha here belongs to the first quadrant. I can even write it down that alpha belongs to the first quadrant. Alpha belongs to the first quadrant. I'm making that endpoint more visible, like a bigger dot. And I am going just to show y coordinate, because again, it is affiliated. This point, let's say, has A, B coordinates. So this is my B right here. So sine of alpha equals to that B. Sine of alpha equals to that B. I will show right now another angle, which will be from the fourth quadrant, because if you look at shaded regions, you definitely can see that we are using fourth quadrant and first quadrant only here. Let's say this time I use angle beta, beta, and beta has endpoints as a pair, C, comma, D, coordinates of that new end point. But this is the point which is for angle beta. But again, we are talking about sine. So I again make perpendicular to y-axis, because again, I'm talking just about y coordinate. And now I can write that sine of beta is C. We already talked about alpha and beta. Can I say that alpha and beta, they fluctuate between negative pi over 2 and pi over 2? Ladies and gentlemen, I ask you a question. Can I say that alpha and beta as angles located between negative pi over 2 and positive pi over 2?
Yes.
Yes.
So how can we write this mathematically easily? Alpha comma beta greater or equal to negative pi over 2. I will write this as a one sentence. And pi over 2. Negative pi over 2 less or equal alpha comma beta less or equal to pi over 2. So if we start reading with alpha and beta, you can see alpha and beta are greater than negative pi over 2, but they are less or equal to positive pi over 2. And in the same manner, I would like to right now talk about fluctuation for C and B, or B and C, if you like, if we do that in alphabetical order. Can you help me with B and C? What do you think about the interval to which they belong to? Do you see the location of B on y-axis?
Yes.
Yes.
What would be the maximum value in this particular circle for y? Don't forget, radius is 1. What would be the maximum value?
√3/2?
No. Square root of, did you say square root of 3 over 2?
Yes.
Okay, approximately square root of 3 is 1.7. 1.7, if we divide by 2, I'm talking about quite rough approximation. So it will be 0.85. But what if, let's say, our angle is pi over 2? I showed alpha, which is smaller than pi over 2. What if our alpha equals pi over 2? What would be the y coordinate?
1.
1. Is it greater than 0.85?
Yes.
So I'm repeating my question right now. What is the maximum value for y in this shaded region?
1.
Definitely. This time it is correct. So which means we can already write that B and C both cannot be greater. They are less greater than 1. They are less or equal to 1. Now, excuse me, please. Now, please look at beta angle and pretend that it moves more down, reaching negative pi over 2. If beta equals negative pi over 2, what is the minimum value of y?
-1.
Absolutely correct. So, and now we have and interval for angles and interval for values of sines for that particular angle. Why is it so important? Because practically that restriction for alpha and beta right here, it tells us that we were correct right here when we wrote down that domain should be equal to the segment we can say segment, we can say closed interval between negative pi over 2 and pi over 2, because it's right now here we can see verification of that. But this piece is a little bit actually different. This piece shows how values of sines for these angles can fluctuate. In other words, if we have in that shaded region y equal to sine x, domain for that is segment from negative pi over 2 and positive pi over 2, but the range is segment negative 1, positive 1. Did you write it down?
Yes.
Yes.
Excellent. But now, why did I spend so much time talking about domain and ranges and how, let's say, x values, which are represented by angles, and y values fluctuate? Because now we can talk about inverse sine. Excuse me. This textbook only is using the symbol which matches the symbol which is in your calculators, but it is not a traditional, more commonly used symbol for inverse sine, because inverse sine has its full name. It is arc sine of x, arc sine. And I will show you both symbols. Definitely, I will be widely using that symbol, which is being used in this textbook. But for example, in other class, which I also teach during this semester, pre-calculus, they are using this arc sine traditional symbol. You need to know that other symbols exist in other textbooks. And because I do not want to see you, let's say, moving to upper level of class, let's say pre-calculus, and say, oh, but we never saw that symbol. This is why I would like to ask you again, remember that this is not the only symbol which is being used by your textbook. We are going to now use that symbol which is being in the textbook. I'm going to write it down. Now, so this why I'm going to write fx equal to sine x, like below that, y equal to sine x, or fx equal to sine x, and inverse for inverse sine function. Y equals this, how you can write it down. Y equals sine minus 1x. This is inverse sine. It is not negative first power. It is a symbol for inverse sine function. Or y equals arc sine x. This is the symbol, more traditional, older symbol, much older symbol than sine minus 1x. But it is not in your textbook, but it is in pre-calculus textbook. ARC. So what I'm going to do, I'm going to probably more often use that sine minus 1x because it is in your textbook, but I will call it arc sine x because it is full name. Is it okay with you?
Yes.
Yes.
Again, I will be more often using in your class sine minus 1x. but I will call it by its full name, because full name of that is arc sine x. Nickname is inverse sine. Many of us, we have full name and we have nicknames, right? Same thing with that functions. But what is really important, if you recall your old material from Algebra 1, you should remember that there is a special relationship between direct functions and inverse functions. If we talk about their domain and ranges, they have switched relationship. Domain for the direct function becomes a range for its inverse, but the range for direct function becomes a domain. So this is why I'm going to use indices like D1, R1. You can add these indices right here. You can see R1 and you can see here D1, which means these are domain and range for the first function. In our list of functions, first function was a direct sine function. Now I can write down that information about domain and range for arc sine, because the D2, which is domain for arc sine, is equal to the range. It equals to the range of the first function. But the range will be equal to the domain of the first function, because they have, and I will even show this like with lines showing that they have that type of relationship. And now, actually, this is the most proper time right now for us to define arc sine x. Are you ready?
Yes.
Not only domain becomes a range and the range becomes the domain. The variables which we have in our functions, they also switch their actually positions. That one which was an independent variable in the first function, it becomes a function for the second one. But a function in the first one becomes an independent variable. Let's analyze what we have in that form, y equals to sine x. Look precisely at what you just wrote on your paper. Y equals to sine x. X, is it playing a role of an angle?
Yes.
Is it just one person's opinion?
Yes.
Yes.
Yes. Okay. Thanks that other people also share. Yes. If we have a direct function y equal to sine x, x is an angle. It represents the angle, like sine of 30 degrees or sine of pi over 2, and etc. X is an angle. What about y? What does it represent? Is it an angle? No, not anymore. Do you remember? It should give you an information about y coordinate, or as we say, affiliated with y, because if it is not a unit trigonometric circle, sine, according to its definition of any angle, will be a ratio of y coordinate to the radius of that circle. This y, what do we have? Y coordinate, is it a number?
Yes.
Yes.
Yes. Radius, length of the radius, is it another number?
Yeah.
Yes.
If we divide number by a number, is it a number as a result of that division?
Yes.
So if we already concluded that, it means what? Y equal to sine x has x representing an angle, y representing a number. But if we start talking about inverse, positions should be switched. Now, in y equal to arc sine x, your x will be a number and y will be an angle. So, and now if we start thinking about the meaning of arc sine x, it is so-called a main angle, sine of which equal to that x. Can you write this definition, please? This is actually definition of arc sine x. Are you ready? I can repeat if you need.
Okay.
Would you like to ask me to repeat?
Yeah.
Yes.
Yes.
Please.
Arc sine x, and you can write this like sine minus 1x if you like, is a main angle. In parentheses, you can write in the trigonometric circle, close parentheses, between negative pi over 2 and positive pi over 2, whose sine is equal to x. Is the main angle in the trigonometric circle between negative pi over 2 and positive pi over 2, whose sine is equal to x. And we can talk about some examples to clarify that situation. And I'm going to use very easy angles, which we covered long time ago. Let's say sine of 30 degrees. What is the value of the sine of 30 degrees, ladies and gentlemen?
Okay, 1 or 2.
1/2.
Can we say simply 1/2?
Yeah.
Okay, excellent. And I wrote it down right here. Sine of 30 degrees is 1/2. Now, 30 degrees angle. Is it so-called main angle here? Is it in the first quadrant?
Yes.
Yes.
Why do I say so? Because not if we talk about entire circle, there will be not only one angle whose sine will be equal to 1/2. It will be 30 degrees angle. That if you, let's pretend that our alpha is 30 degrees angle. What can you do? Can you expand that line to reach another side of the circle? Yes?
Yeah.
And you
Yes.
will get another point. And for another point, angle will be 180 minus 30 degrees, which means 150 degrees angle. So at least in one revolution, in one cycle, two angles will have sine equal to 1/2. One is 30 degrees angle, another is 150 degrees angle. This is why we ignore quadrant number 2 and quadrant number 3, because if we can see consider entire circle, the sign will be not invertible. This is why we talk about only one angle, main angle. But look what I'm going to do. I wrote this in the traditional form as we did many times in this class, but now I will be using that information about inverse functions, which we just talked about. Angle becomes a function. Excuse me, I have an allergy because I'm taking some medicine because of the blood pressure. My blood pressure plays dirty game with me. And this is why I'm coughing. I don't have a coronavirus, thanks God, so far. So now I'm going to write this like arc sine, which is sine -1 parenthesis of 1/2, or you can use parentheses or not, up to you, equals to 30 degrees. These are two different sentences. They look different, but they carry the same mathematical meaning. In the first sentence, we state that sine as a function of 30 degrees angle is 1/2. In the second, I'm stating that 30 degrees angle is the main angle for which sine is equal to 1/2. Do you understand what I'm talking about?
Yes.
Is it just one person?
Yes.
No, yes.
Because again, knowing that sine of 30 degrees equals to 1/2, I know that 1/2 is the value of the sine for what kind of angle? 30 degrees angle. This is what I wrote in the second sentence. Let's do something different. Let's say sine of 45, I'm going to write this actually not 45 degrees, pi over 4. Sine of pi over 4 or 45 degrees equals to what?
Root
45
2 over 2.
Square root of 2 over 2. If I decide to rewrite this sentence in terms of arc sine, what should I write? Can you help me, please?
Okay.
Wouldn't it be sine to
No,
the
it is not. You cannot call it sine anymore. You can call it inverse sine or arc sine.
inverse sine?
Okay. Arc sine or inverse sine of what?
Root 2 over 2
Right.
equals pi over 4.
Exactly. It is equal to pi over 4. Absolutely correct. That now we know that which angle has sine equal to square root of 2 over 2, pi over 4. Now, what should we do if we have, let's say, negative angle? I'm going to write now this sentence for negative pi over 3. Sine of negative pi over 3. Negative pi over 3. Is it from that dashed region, ladies and gentlemen?
Yes.
Is it just below x-axis, right? In the fourth quadrant. But how can I simplify that? Sine, is it an even function or odd?
Odd function.
What can I do with that minus?
Bring the negative sign to the front.
Absolutely good advice. Minus sine of pi over 3. So we know it will be negative, but it makes sense because for any point in the fourth quadrant, y coordinate is negative because it is below 0. So by the way, what is the value of the sine of pi over 3?
Root 3 over 2.
accepted. Voila. I wrote it down. Negative square root of 3 over 2. So then what? How can I write this in terms of arc sine? Who can help me?
Would it be inverse sine?
Okay, one sec. I'm writing down symbol of inverse sine, yes.
Of
Or
negative square root of 3?
definitely, because it
over
is
2.
negative. Yes. Negative square root of 3 over 2. Yes. In this case, you need to use parentheses equals to what?
Pi over 3?
No.
Negative pi over 3.
Negative pi over 3. Yes, absolutely correct. Negative pi over 3. Negative pi over 3. Again, arc sine is the main angle in the trigonometric circle, which can be chosen only from the fourth quadrant or the first quadrant. I'm even starting with the fourth because it has negative angles here. From the fourth, or if you like to say, you can say between negative pi over 2 and positive pi over 2, for which sine is equal to that x. Did it click a little bit in your minds?
Yes.
I know, because it is a little bit confusing. So what I'm going to do, what is time right now? According to my watch, it is 1:12. Okay, I am declaring 5 minutes break, and after that, I will continue solving problems from exercises. So rest a little bit and come back, and please be on time, okay?
Okay.
Okay, rest a little bit. Guys, can you hear me?
Yes.
Yeah.
Okay. What is the time right now?
Yes.
Oh, 1 minute more. Are you back?
Yeah.
Yes.
Yeah.
Yes.
So let's continue. By the way, do you need again this paper because I don't have space here anymore? Can I move to another piece?
Okay.
Yes.
Okay.
Thank you. I'm using sketch papers. So, I moved to another page. It is page 192. And I'm going to randomly choose right now several problems, and I will solve them with you. Definitely, I will explain everything. Are you ready?
Yes.
Yes.
All right, on the top, we have problems from 13 to 24. And let's see what we have to do here. In problems 13 to 24, find the exact value of each expression. Excellent. And so far, I just talked about arc sine. This why at the beginning, I will choose problems with arc sine, but I promise you, I very briefly will explain you similar material about cosine and arc tangent. So for example, problem number 13. What do we have here? We have arc sine of 0. Arc sine of 0. What should you start thinking about? In that particular region, fourth quadrant in the first quadrant, which angle has sine equal to 0?
2 pi.
Can you repeat, please?
2 pi.
No. 2 pi we cannot reach. You are correct. Sine of 2 pi will be 0. But do we have much smaller angle for which sine is also 0?
0.
That's it. Because 0 degrees or 0 radians or 360 degrees or 2 pi in radians, do they share the same point?
Yes.
It means in the circle, they share the same endpoint. It means they have the same y coordinate. Definitely. That's it. You found correct answer. So yes. So what I'm going to do, I just will simply write that arc sine of 0 is 0. 0 radians, because we mainly will be here having our answers in radians. But if you like to write this, actually I will write it down, but in your Pearson, all answers are stored in radians. But if you like to write this in degrees form, voila, this is what you can write. Arc sine of 0 is 0 degrees, because the answer here is an angle. Did you understand?
Yes.
Yes.
Excellent. Look at number 15. Arc sine of -1. Arc sine of -1. In the same region, fourth quadrant up to first quadrant, if we move up. which angle has sine equal to -1?
3 pi over 2.
3 pi over 2, we cannot say because we do not have here the second quadrant and the third quadrant. Your answer is correct.
Is it negative pi over 2?
Absolutely, yes, because 3 pi over 2 is this 3 pi over 2 angle shares the same endpoint with negative pi over 2.
Yes.
That's it. The answer is negative pi over 2. Did you understand how we work here?
Yeah.
Let me do the last one, and after that, I will continue talking about arc sine and arc cosine and arc tangent. What about 22? Are you okay with number 22?
Yes.
What do we have here? Arc sine of negative square root of 3 over 2. Let me teach you small trick which can help you to work easier with that type of problems which have negative sign in parentheses. Ladies and gentlemen, if you have arc sine of negative number, just take this minus to the front. Minus arc sine of positive square root of 3 over 2, and we will be very easily now getting the answer. Now just think about what? Which angle has sine equal to square root of 3 over 2?
60.
But what if about radians? In radians,
Negative pi over 3.
right? Absolutely correct. The answer here is negative pi over 3. Is it clear?
Yes.
Excellent. And now here on this side, I am going to write information about, again, arc sine. We already talked about that. Arc cosine and arc tangent. They are all have very similar definitions. Same thing like arc sine was the main angle from certain interval. Arc cosine will be another main angle from also certain interval, and as well as tangent. Let me show you what I mean. And please consider that each time now we are not going to use entire circle. We will be using only half of the circle. And this, what I'm showing, oops, let me show 0 as well. Can you see what I showed?
Yes.
Yes.
I can't even name that quadrant. Quadrant number 4, quadrant number 1. Look, I was more precise. In other words, I can write that arc sine of x is between pi over 2 and negative pi over 2 as we got our answers for our problems. We actually already talked about that. Now I'm going to talk about arc cosine. It is not the same half of the circle. It is a different. If we can talk about right half of the circle for arc sine and actually for arc tangent, not anymore for arc cosine. For arc cosine, we will be talking about the top part of the circle. It will run from 0 to pi. So this time it is first quadrant and the second quadrant, also half of the circle, but only the top half of the circle. Let me finish that information about arc tangent as well. And after that, we will be able to solve problems, all problems from that spot. This is what I write down. So if basically, if I like to define right now arc cosine of x, it is the main angle in trigonometric circle between 0 and pi radians, for which cosine is equal to x. Very similar to what we just talked about arc sine function. Only this time it is a different part of the circle. If for arc sine it was the right half of the circle, for arc cosine it is the top half of the circle. And I now can offer you one of these problems now using arc cosine. Example here. Problem number 14. Arc cosine of 1. What would be arc cosine of 1? You need to think about angle or from the first quadrant or from the second quadrant for which cosine will be equal to 1. Which angle has a cosine equal to 1 from declared region?
Would it be 0?
Absolutely correct. Equal to 0. I do not see any attractive actually value of arc for arc cosine here. So I'm going to create my own. I will call it like 14 star because it is not from your textbook. I'm going to write it down by myself. So arc cosine of 1/2 arc cosine of 1/2. Which angle from first or the second quadrants has cosine equal to 1/2? Give it in the radians, please.
Pi over 3.
3?
Yeah, which is absolutely correct answer. Yeah. Now I would like to repeat something what I repeated many times. Well, all these values of trigonometric functions, are they extremely important?
Yes. Yes.
Is it extremely important to know that when really better than many other things probably, yes?
Yes.
Because this material is completely based on that information. If you don't know that values, if you are not good friends with these values of all these trigonometric angles from that tables, which we learned in chapter number 2, this material will be very difficult for you. Let me show right now easy formulas for arc sine and arc cosine, and I will do that later for arc tangent. For that cases when we have negative sign. So arc sine of minus x equals minus arc sine of x. But for arc cosine, it is different. We cannot drop that minus as we did for regular cosine, because regular cosine was an even function. So if we have, let's say, cosine of positive 30 degrees, or we have cosine of negative 30 degrees, they will share the same value. It will be positive square root of 3/2, but not here. So unfortunately, this textbook has different, much more difficult approach to this type of problems, I will give you right now very easy looking formula. These are two formulas, and I will later write down. Please write them down. That arc sine of minus x is negative arc sine of x, but for arc cosine of minus x, look what we have. We have pi minus arc cosine of positive x. Can you see?
Yes.
This why we can easily right now look at problem number 23 in your textbook. I saw that problem, this is why I gave you that formula. What do we have here? We have arc cosine of negative square root of 3 over 2. Negative square root of 3 over 2. What should you do? You should apply that formula. So it will be what? It will be pi minus arc cosine of positive square root of 3 over 2. First step, pi minus arc cosine of positive square root of 3 over 2. And now, please recall that information. Which angle from the first or the second quadrant, practically it will be from the first quadrant because there is positive now square root of 3 over 2. Which angle has cosine equal to square root of 3 over 2?
Pi over 6.
That's it. So minus pi over 6. So pi minus pi over 6 is 5 pi over 6. This is your answer. 5 pi over 6. This, trust me, ladies and gentlemen, this is the easiest way to solve that type of problems. Can I talk about arctangent right now?
Sure.
So, for arctangent, we are going to use same side of the circle as we used for arc sine, but with small difference. Why? Because if you look at the shaded part of the circle for arc sine, what do you see there? Do you see that we can use negative pi over 2 and positive pi over 2?
Yes.
But now let's connect these angles with tangents. What is the value of the tangent of pi over 2?
Undefined.
Undefined.
Right, it does not exist as a value. What about tangent of negative pi over 2, which is the same thing like tangent of 3 pi over 2? What is the value?
0.
No,
Oh, sorry.
3 pi over 2.
it is also undefined.
3 pi.
So which means, yes, we will be using right side of the circle, but we cannot use endpoints. How can we show that? Easily. We now can show again the same right side of the circle. The only difference now is we will be having open circles at these 2 points, negative pi over 2 and positive pi over 2. Look what I showed. Can you see that open ends?
Yes.
Which means we cannot include that points, negative pi over 2 and pi over 2 into the range of that function. because we are showing here the ranges of that functions, angles. But all angles between negative pi over 2 and positive pi over 2, excluding negative pi over 2 and pi over 2 themselves, will be representing main angles, which are arctangents, because arctangent is the main angle between negative pi over 2 and pi over 2, not including endpoints, for which tangent is equal to x. So in other words, no equal signs anymore, only strict signs of inequalities. Look what I wrote next to that circle. Negative pi over 2 is less than arctangent x less than pi over 2. No equal signs anymore. At the same time, can you see I completed that box? Can you please write the formula for arctangent of negative x? It reminds us a lot the same type of formula for arc sine of negative x. Did you have an opportunity to write it down?
Yes.
Yeah.
Okay, and now I'm going to solve some problems from the same spot that this time about arctangent. An example, I'm going to grab one of examples, 17. Arc tangent of 0. Which angle in the right half of the circle, oops, technical problem. Which angle in the right half of the circle has tangent equal to 0? Actually, today's lecture is a good review for coming test. Excuse me, I did not hear the answer.
Pi.
No,
What?
pi is not there. It is on the other half of the circle.
Oh.
Is it 0 radians?
Yeah.
Yes.
I can see probably you forgot that pi as well as cotangent are pi periodic. If it is correct for pi, which is correct, so it will be correct for pi minus pi or pi plus pi. Pi minus pi is 0. It is 0. 0 radians. That's it. 0 radians. Please review all these values, guys. Now, let's say I'm solving problem number 20. Oh my God, I solved already so many problems from this spot. Arc tangent, square root of 3 over 3. And again, this is really good exercises to review all these values. Look, isn't positive square root of 3 over 3?
Yes.
It means what? We have in our possession 2 quadrants, fourth quadrant and the first quadrant. If you have positive number, what would be your quadrant? Definitely the first one. So which means, think about angle from the first quadrant for which tangent should be equal to square root of 3 over 3.
30.
How can
Pi over 6.
how can you convert this into radians? In radians, it will be what?
Pi over 6.
That's it. This is the answer. Pi over 6. Pi over 6. And the last problem I like to have, there is no, I do not see here, tangent of negative numbers. I'm going to write this by myself. I will call it like 20 star, 20 with star, because I'm creating my own problem. Okay, arc tangent of parenthesis, negative square root of 3. Negative square root of 3. If you look into box, you can see the last line, which can help us to deal with this problem. What can I do with this minus? Can I take it all the way to the front?
Yes.
So do that. So it will be minus arc tangent of positive square root of 3. And now, definitely answer will be negative. But which angle has which angle has tangent equal to square root of 3?
Pi over
Pi
3.
over 3.
Pi over 3. If you like to recall it in degrees also, it is acceptable, but right answer in radians. So voila, this is your answer, negative pi over 3. I do not want to solve right now during our today's lecture problems from 25 to 36. I will do that the next time. It is about how to use calculators to find approximate values. Yes, in our calculators, we have 3 buttons, one for arc sine, another for arc cosine, the other one is for arc tangent. I will show that later. But I would like to mention one important property for inverse to each other functions. They have very nice property. I'm going to remind you about this property. It is property which you can see in the composition of two functions. F applied on the top of f minus x equals to x. F applied on f minus 1x, which means here f is a direct function, f minus 1 is inverse. If that x, which you have inside of all parentheses, is in the domain of outside function, your answer will be x all the time. But it is a very important detail. That x which you see in this sentence should be in the domain of the outside. I said in domain two, in the range of outside function. That x should be in the range of outside function. That it works in different way as well. In the switched composition also, we have same requirements and same type of result. If we have now composition f minus 1 by f, which means inverse f composed with f, answer also will be x if that x is in the range of f minus 1 function, which is the outside function. And you have here, excuse me, talk too much. With my allergy, I need to talk a little bit less. You have the spot from number 37 to 44 where we can apply this knowledge. And I have 5 more minutes to end the class during talk too much.
Want some water?
It's okay. I will try to concentrate. The bad thing is right after your class, I have another lecture with pre-cal. So, arc cosine, number 37. This is the problem. This time it is a composition. And I'm going to read what we have to do here. In problems 37 to 44, find the exact value of each expression. Do not use a calculator. But what do you see here? Is it a composition of functions? Yes, because arc cosine should be applied on the top of cosine of 4 pi over 5. Are they inverse to each other, arc cosine and cosine?
Yeah.
Yes. Now, 4 pi over 5. Is it in the range for arc cosine? What is the range of arc cosine?
Pi.
Right here, from 0 to pi. You can even convert this into degrees. It is easier for you. 4 pi. Is it 720 degrees?
Yes.
Excellent. If you divide 720 by 5, what do you get? 720. 144 degrees?
Yes.
Is it between 0 and 180?
Yes.
In other words, is it from the second quadrant?
Yeah.
Second quadrant, is it a part of the range for arc cosine?
Yes.
That's it. Answer here is 4 pi over 5. So you are very lucky if that value inside is in the range of the most outside function. In this case, it will be just the answer. For example, I'm going to right now do problem number 38. Probably it will be the last one for today. Arc sine of negative pi over 10. Arc sine of negative pi over 10. These two functions, are they inverse to each other?
Yes.
Yeah, because sine x, arc sine x, inverse to each other. It can be that kind of composition, inverse with direct or direct with inverse, doesn't matter. Answer is yes, they are inverse to each other. Now, look at negative pi over 10. What is the equivalent of negative pi over 10 in degrees? Pi, is it 180?
Yes.
Yes.
If you divide by 10,
18.
is it 18? Attach negative, is it negative 18 degrees?
Yeah.
Yes.
What is the location for negative 18 degrees? Which quadrant?
The fourth quadrant?
Definitely fourth quadrant because it is below 0. For arc sine, we are using only first quadrant and the fourth quadrant. Is it in the fourth quadrant?
Yes.
Is it in the range of arc sine?
Yep.
What would be your answer here?
Negative pi 10 over 10.
Right? Absolutely, yes. Negative pi over 10, and you have your answer. But next time I will show you when our answer has negative, when our question has negative answer. Let's say, yes, they are inverse to each other, but no, this is not in the range of the outside. I will show you how to solve that problems as well. I am done for today. Please be on time next time because I will open test on Pearson. It will be very similar to what you do solving problems from homework or online quizzes. Only this time you will not have 2 days or 3 days, even 1 day. You will be having very limited time bracket. It will be limited to 1 academic hour. Is it clear to everyone?
So basically we signed into Pearson at exactly 10:10.
if you have maybe other device as well, it would be nice to have it both, but yes, because you will see that assignment. Probably I will maybe greet you at the beginning. I will not start right with the first minute. So I recommend you to come to our Zoom conference at the beginning. And after that, after about 5-6 minutes, you can start your test. Is it clear?
Yes.
Yes.
Excellent. Please review all formulas, all values, and properties of what we covered, okay? With your permission, can I say everyone warm goodbye?
Bye.
Yes.
Okay, guys, stay well, okay? I
Bye.
will see you the next time. Bye.